Lab 1, Charged Tape. The goal for this lab is to use household objects to gain a visual frame of reference for how charges interact and to determine an approximation of the excess charge on one piece of charged clear tape. After conducting the experiment and observing the interactions between the tape and other objects, I was able to approximate the amount of charge on one piece of tape. My results showed that tape B had a charge of 1.7993 times 10 to the negative 9 coulombs. There were 1.2459 times 10 to the 10 electrons on the tape, and the ratio of excess electrons to atom on the tape was 5.47. In this video, I will address the assumptions, calculations, results, and Python code I used in the lab which allowed me to obtain these results. Here are a list of the assumptions I made during the lab. I assumed the gravitational force and the electric force were the only forces acting on the tape. Treated the tape as a point charge with evenly distributed charge across each tape, and that clear tape is around 1 gram per meter. Because this lab involves the analysis of charges and how they work, the fundamental physical principle of Coulomb's law plays a large role in the lab. Coulomb's law states that the interaction between charged objects is a force that acts over some distance of separation where like charges repel and opposite charges attract. We will see Coulomb's law in action when placing a charged piece of tape near household objects. The first part of the experiment was to observe how the U-tape interacted with another U-tape and other household objects. Shown are the interactions of the U-tape and the corresponding object. I rubbed the pen against my hair to create a negative charge, and its attraction to the U-tape shows that the U-tape is positively charged. When I placed the two U-tapes together, they repelled, and I measured the displacement of the floating tape. I measured and recorded the length and mass of tape B. The displacement of the floating tape B was 0.0038 meters, which occurred when I put the two on top of each other, and I noted the repulsion that happened and recorded that distance. These measurements were used to calculate the forces present, which are shown by the free body diagram. Because the forces are at equilibrium, the electric force is equal to the gravitational force. Both the magnitude of the gravitational force and the magnitude of the electric force are 0.0020179 newtons. Next, I had to calculate the charge on tape B by using the previous equation and solving for Q to find the charge on tape B. Once I calculated the resultant charge, I used this value to find the number of electrons on the piece of tape by dividing it by the charge of one electron, which is 1.6 times 10 to the negative 19 coulombs. Next, to calculate the number of atoms on the sticky surface of the tape, I used the equation length of the tape divided by an atom length, which is 1 times 10 to the negative 10 meters. Lastly, I calculated the ratio of excess atoms on the surface of a sticky piece using the equation number of electrons divided by the number of atoms on the sticky surface. I found the ratio to be approximately 5.47 excess electrons per atom. For my code, I used Python. I started by adding all of the measurements and constants. I then wrote out functions for the gravitational force and electric force on tape B. I also wrote a function for the charge of the tape as Q. In this part of the code, I wrote functions for the number of electrons on tape B, the number of atoms on the sticky surface, the ratio of the number of electrons to the number of atoms on the sticky surface. I also wrote a line of code for the particles which represent tape A and B, and then arrows for the forces acting on the tape, which were the electric force and the gravitational force. Here is a computational model of the two particles and the forces acting on them. The orange ball on the bottom is tape A, the green ball is tape B, the pink arrow is the force of electrostatic attraction pointing up, and the blue arrow is the force of gravity pointing down. The values output match the values I calculated using the equation shown earlier. Question 1. Since like charges repel and opposite charges attract, this change would not have an effect. It would just be a matter of recognizing what charge is positive and what is negative. There will be no change in the observations of the interactions of the U-tapes and other household objects. Question 2. When the tape touches the other objects, the charge of the tape will be altered by the transfer of electrons between objects. If the charged tape meets a neutral object, like a hand, the electrons will be transferred to the more neutral object, which would change the charge of the tape. By handling the tape as minimal as possible, the correct interactions between the tape and other objects can be observed. This lab demonstrated the transfer of charges between household objects and reinforced physical principles such as Coulomb's law, the electric force, the gravitational force, and electric fields. Through this lab, I found a charge of 0.2057 meter U-tape and the ratio of excess electrons per atom.